God bless you, student. Today we start our chapter number 4 and class 7th. Chapter name is Scarce and Square Root. Now, we have to solve these questions by prime factors. Now, here is a square root by prime factors. Now, exercise number 4A. Exercise number 4A. Now, question number 1. It's the part 1. Here is the find the factors, the positive square root of 5 to 9. 5 to 9. As you find it's by prime factors, we can solve these questions directly by 23. So, this is divided by 23. So, 23 divided by 1 times. So, its prime factors are 23 multiplied by 23. So, it means 23 whole square by square root we can write as its answer is 23 by prime factors. Now, dear students, we solve the question 1 and its second part. Its second part is 1024. So we have to find a square root by prime factorization. So first of all, we write 1024 and find its prime factors. First of all, you have to divide by 2 5 times, 1 time, 2 times. Then you can divide by again 2, 5 and 6. Then 2, 1, 2, 8. Again you divide by 2, 64. 2, again 32. And then again you divide by 2, 16. And 16 divided by 2, 8 times. And again divided by 2, 4 times. Then 4 divided by 2, 2 times. And 2 divided by 1 time. So this is our prime factorizations. Now find its square root. So 1024 square root we can write as 2 into 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 2 and we can write here 2 into 2. Now it's a square root and we also write it's these are the pairs, and pairs it means you have a square. 2 whole square multiplied by 2 whole square multiplied by 2 whole square multiplied by 2 whole square and multiplied by 2 whole square. And again we can write as 2 into 2 into 2 into 2 into 2 whole square and whole square root. As you know, square is cancelled by square root and we can write as 2 into 2 into 2 into 2 into 2. And when we multiply these two, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. 16 into 2, 32. So here is 32 and this is your answer because 1024 its square root is 32. So this is your answer. Now student, we have in question number 1, part number 4, as we have solved part number 2, same pattern. Now, first of all, we find its prime factor, 64. Now, first of all, you divide by 2, so 8, 8, 2. Again divided by 2, 4, 4, 1. Now, divided by 3 times. 3, 1 time, 3, 4 times, and 3, 7 times. Then 3, again, 3, 4 times, and 3, 9 times. Now, then you have to divide it by 7. 7 sevens are 49. Again, 7 divided by 1 time, 7. Now, students, here is prime factorization. Now, find its square root. How can we find its square root? Here is 1764. It's the square root. So we can write as 2 into 2 into 3 into 3 into 7 into 7. It's the square root. Now, from here we have this is pair, this is pair, this is pair. We have 3 pairs. It's the power 2 power 2 multiplied by 3 power 2 multiplied by 7 power 2 square root. Now we can write as 2 into 3 into 7 whole power 2 square root. As we know, it's the square root, its value is 1 by 2 and square is cancelled by 1 by 2 and then we have 2 into 3 into 7. So 2 multiplied by 3 is equal to 6 and 6 multiplied by 7 42. So your answer is 42. This is your answer of 1764. It's a square root. Okay. Now student, question number 1 is the last part 12 44100. Now we have to find its square root by prime factors. So here is 4 4 1 0 0 and we have to find its prime factors. Divided by 2, 2, 2, 0, 5, 0. Then again you have to divide by 2, 1, 1, 0, 25. Now you have to divide by 3 or 5. 5 divided by 5. Now here is 5 2s are 10. 2, 2, 0, 5. Right? Now, you have to divide by again 5. 5 4s are 20. 5 4s are 20. 5 1s are 5. Now, divided by 3 times. 1, 3 4s are 12 and 7 3s are 21. Now again 3 4s are and 3 9s are 27. Then 7 sevens are 49 and lastly divided by 7 1 times are 7. Now we can write it's a square root. So square root we can write as This is equal to 2 into 2 into 5 into 5 into 3 into 3 into 7 into 7 square root. And we can write as it's a pair, 2 square multiplied by 5 square multiplied by 3 square multiplied by 7 square root. And also we can write as 2 multiplied by 3 multiplied by 5 multiplied by 7 whole square root. As we know that square is cancelled by square root, and we have to write as 2 multiplied by 3 multiplied by 5 multiplied by 7. Now, here is equal to 6 multiplied by 5 multiplied by 7. So 6 multiplied by 5, 30 multiplied by 7. 30 multiplied by 7 is equal to 210. So 210 is your answer, and this is a prime factorization of a 44100. Its a square root is equal to 210. This is your answer.
Hello students. Question number 2. These are the questions with statement and or the word problem, we can say. This is a word problem. Find the smallest whole number by which 512 must be multiplied in order to give a perfect square. It means that 512 is not a perfect square. By which number 512 must be or should be multiplied that it becomes a perfect square. For example, if I say that 8 is not a perfect square because we cannot find a number which multiplied by itself gives 8. There is no number. So if 8 is not a perfect square, so can we find any number by which we multiply 8 and then we get a perfect square? Think over it. Yes, you can say that, sir, if we multiply 8 by 2, then we will get 16, and 16 is a perfect square. 16 is a perfect square because 16 is a square of 4. Similarly, in the same pattern, if I say that 16, then 16 square root is 4 or plus minus 4. Same pattern, we can solve this question. So 512 is a given number and we want to find a number by which 512 should be multiplied in order to give a perfect square. So let's see how can we find this. Okay, if I want to find 8 by which 8 should be multiplied, let's see. If I make the prime factors, 2 4s are 8, 2 2s are 4 and 2 1s are 2. So 8 is not a perfect square because the numbers in the prime factors are not in pairs. The numbers in the prime factors are not in pairs. Here is a pair of 2, but there is something lacking, and that number is also a 2. So if we say that we want to make the pairs of the prime factors, then we will have to multiply it by 2. Now, two pairs of 8, 2 pairs are there. From this pair, we can take 2, and from this pair, we can take 2. So the answer will be 4. I think that if I don't solve this question, now you can solve this question. So in the same way, now we will solve this. Solution. 512 is a given number. Given number 512. Okay, so we will make the prime factors of 512. 512 and its prime factors. 2 2s are 4, 2 5s are 10, 2 6s are 12. Again by 2, 2 1s are 2, 2 2s are 4, 2 8s are 16. Again with 2, 2 6s are and 2 4s are 8. Again 2 32 and 2 16s are, then 2 8s are, then 2 4s are, 2 2s are, and then 2 1s are. Now look at this. As in the example I have told you that there should be the pairs in the prime factors. Are there the pairs complete? 1 pair, 2 pair, 3 pair, 4 pair. This 2 is not paired. So we will have to make the pair of these two. We will have to multiply our number by 2. So the required number, what will be the required number? Required number is 2. Because we cannot find the pair of 2. Okay, you can write it as I have already written it as if there is a no pair in this. So similarly you can write this number also. But the concept is this: if there is a no pair of any number, then you should write as answer. So that is our required number. It means that if we multiply 512 by 2, it will become 1024, and 1024 is a perfect square of 32. Let's do the next question. Okay, students, one more question. Word problem. The product of two positive numbers is 15876 and the larger one is 9 times the other. Find the numbers. We don't know two numbers. What is the larger one and what is the smaller one? But their product is given 15876. And we know that the larger one is 9 times bigger the smaller one. So we can solve this question using the algebra. If we let the smaller number is x, let the smaller number equals x, and let the larger number 9x. Now, as the product is given to us, we know that product is equal to 15876. So what will be the product of these two numbers that we have supposed? First one is x and the second one is 9x. If we multiply these two, 15876, so that it will be 9x square. 15876, and if we divide it, here the 9 is multiplied by x square. If we take it to the other side of the equality sign, then it will be divided. Now x square is equal to 15876 divided by 9, and the answer is 1764. Now students, what we can do now, we have to take the square root of both sides. So we will write here, taking square root of both sides. So we will take the square root of both sides, x square square root, as well as the square root of 1764. Okay, prime factorization method we can use. We can make the prime factors in rough column. I will make the prime factors of 1764 here. Okay, if I do it, 2 8s are 16, 2 8s are 16, 2 2s are 4, again 2 4s are 8, 2 4s are 8, 2 1s are 3 1s are 3, 3 4s are 12, 3 7s are 21, 3 4s are 3 9s are, then 7 7s are, and 7 1s are. So the prime it will be cancelled because the square root sign has the power 1 over 2 and the square power 2. Both will be cancelled. And 1764 square root we can mention from here also, because there are 1, 2 and 3 and one pair of 2, one pair of 3, one pair of 7. So it will be 2 square multiplied by 3 square multiplied by 7 square. Because of the pairs, I have written power 2 there. Okay, now we will write it as 2 multiplied by 3 multiplied by 7 and whole square root. Square and square root will be cancelled. 2 multiplied by 3 multiplied by 7. 7 3 is 21 and 21 2 is 42. So what is our x? Let the smaller number is x. So the smaller number is hence smaller one. Smaller number equals 42 and larger one is 9x. So larger number 9 into 42. So 9 2s are 18, 1 carry, 9 4s are 36 and 1 plus here 37. So 378. So here are our two numbers 42 and 378. Now how can we verify that our answer is correct? So we will directly multiply 378 multiply by 42. Answer should be 15876. And here we multiply and the answer is 15876. It means that no need to verify the answer by the book or from the book. You can just multiply these two numbers. If it is equal to the given product, then the answer is correct. Let's do the next question. Okay, questions number 7, students. That is, in fact, the statement of this question is very long. That's why I couldn't write it on the board. So I will just read and then I will explain it to you and then I will solve. A gardener with 5,770 plants wants to arrange them so that the number of rows of the plants equals the number of plants in each row. When he does so, he discovers that the number of plants falls short by 6. Find the number of rows the gardener wants to make. Okay, number of plants with the gardener. Number of plants, that is 5,770 and fall short 6. Okay, number of rows we have to find. Number of rows, we want to find how many rows the gardener wants to make. Okay, first I will try to explain it with an example. For example, a gardener has only 15 plants. For example, same 15 plants and he wants to make a square. He wants to put one plant, then 2 plant, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Oh my God. He says that if I had only one more plant, I could make the perfect square. Because number of rows are 4 and number of 1, 2, 3, 4 and number of plants in each row is also 4. 4 multiplied by 4, 16 and 16 is the perfect square. But he falls short one plant. That's why he could not do so. So if we want to help this gardener, what will we do? We will say him, if you have 15 plants, okay, arrange some one more plant, then you will have 16 plants, and we know that 16 is a perfect square. But a gardener, he doesn't know. And if we say him that if we add one more plant in this, then you will have equal number of rows, and in each row the plants will be the same, 4, 4, 4, 4. Now I think you have understood what is the problem here. He has 5770 plants and he wants to arrange these plants in the rows so that the number of plants in each row is equal to the number of rows. But he falls short 6 plants. What will we do? First of all, we will add this 6 in 5770 and then we will find the square root of that answer. Okay, let's do it. Okay, what will we do? We will add this 6 into 5770. In order to make it a perfect square, what we will have to do? We will add 5770 and 6. The answer will be 5776. Now, in order to make a perfect square, he has to add these two because 6 plants were less with him. Now, if we have 5776 plants with us, then definitely number of rows will be equal to the square root of this. As I have told you that if we want to find or make it a perfect square, then we will have to add one more. Similarly, we have added 6 in the given number of plants and now we have 5776 plants, and if the number of rows and the number of plants in each row we want to make it equal, then we will have to take the square root of this. Let's take the prime factors of 5776. Okay, we want to find the square root of 5776 and we will make the prime factors of 5776. Let's do it with 2. 2 2s are 4, 2 8s are 16, then 2 8s are 16 and 2 8s are 16. Again by 2, 2 1s are 2, 2 4s are 8, 2 4s are 8, 2 4s are 8. Again 2 7s are, 2 2s are, 2 2s are. Again 2 3s are, 2 6s are, 2 1s are. Now 361. I think that 19 19s are 361. So 19 is a prime number and 19 1s are 9. What will we do? We will write here 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 19 multiplied by 19 and its square root. So 2 square, again 2 square, and then 19 square, and then we can write it 2 multiplied by 2 multiplied by 19 and its whole square and its whole square root. Square and square root will be cancelled. The answer will be 2 multiplied by 2 multiplied by 19. 19 2s are 36 and 38. 38 multiplied by 2, 76. So number of rows that he wants to make is 76. So now if he makes 76 rows, then the number of plants in each row will be 76. Okay, I hope that you have understood by the example, and the answer is also very easy to check, because if we multiply 76 with 76, the answer should be or must be 5776. Okay, students, all the questions of this exercise 4A we have done, and 3 questions from the statement questions I have left, and a few more questions Sasleen has left for you. This is your assignment or your work to do or homework, and I hope that you will do it. Thank you for watching. God bless you.